Hey there, and Merry Christmas morning for those of you that celebrate. Today we're doing day 38 of the NeetCode 150 challenge, where I'll be solving my very first LeetCode medium sliding window problem. And without further ado, let's get straight into it. Ho, 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 which is fitting, because today we're doing problem number 3, as in 3 hoes, longest substring without repeating characters. LeetCode medium. Okay, given a string S, find the length of the longest substring without repeating characters. This makes me curious. What is problem 2 on LeetCode? I'll have to look that up, because I know 1 is 2 some. But okay, enough of the tangent. Okay, so this is just one sentence. Given a string S, find the length of the longest substring without repeating characters. Okay, I'm already thinking of a sliding window idea for it. Are we in the sliding window topic? Okay, we are in the sliding window topic. Okay. So, all right, let's look at an example. So ABC, ABC, BB, right? So output is 3. The answer is ABC with the length of 3, right? So the idea... Yeah. This is actually going to be rather simple, right? So what we're going to do is we're going to say both our left and right pointers, we're going to have 2, are going to be initialized to 0. And the point is we're going to keep going through the string S as long as we don't have a repeating character. And as soon as we have a repeating character, every single time we're going to update our max length, right? But if we have a repeating character, we're going to keep, incrementing from the left side until we no longer have any repeating characters, right? And the way we can do that is actually with a hash map, right? So with a dictionary here. And the point is that we don't have to look through every single character in the dictionary. It's whenever we add a character, we can check if it was already in the dictionary or not, and so on, right? So here, we'll just do this, right? So for a letter in S, we'll do, what should we do this like as a default dict event? Okay, so this will work, but oftentimes I try to avoid using that because I'm not too familiar with anything that's not int. So what I like to do is like, okay, d of letter is equal to d.get letter, and 0 if it's not inside the dictionary yet, plus 1, right? So that way we add 1 to whatever it is, whether it already exists in our dictionary, in which case we're augmented by 1, or if it doesn't, we start off with 0. 0 plus 1 is 1, which means the very first time we see this letter, right? Now, if d of letter is equal to, greater than 1, now we can do while d of letter is greater than 1, actually, we're going to do L plus or equal to 1. We're going to have res is equal to 0. So let me think. We're always going to include, so L and R. Yeah, so we're going to have included R, so 0 minus 0. So really, I just want to do R minus L plus 1, right? Res is equal to max of res and R minus L plus 1. So that's the length. Right. Because, yeah, at the beginning, I'll have, let's say I just have one character. I'll have d of letter is inside of there, right? Here, no matter what, I'll do r plus or equal to 1, right? I can even just do something like r plus or equal to 1. Actually, we can even do for r in range length of S and get rid of that entirely, right? L is equal to 0. of S of L minus or equal to 1 and L plus or equal to 1. Now R plus or equal to 1, we don't need that anymore. And right, so at the beginning we'll have 0. So now we want R minus L plus 1. Okay, and then at the end we return res. So something like this should work. Letter is not defined, right? Because we want letter is equal to S of R. Okay, so this is accepted. Let's submit. And there we go. Bada bing, bada boom. 25 MS, we only beat 25%. We can see if we can do better than others. Also, something I saw is that I had solved before I actually solved it. Okay, so I solved this in June 8th of 2024. Oh, and I have some that go way back all the way up to December of 2022. November 2022. Okay, so I've done this problem quite a bit of times. Oh, even in C# before and so on. Okay, so that's kind of cool. But yeah. Okay. So here we have an accepted solution of 25%. Is it just because, whoa, that is not what I want. Whoa. Stop. I didn't even know you could do a timer. That's actually kind of cool. But okay, let me submit. Is it just variance? Or, okay, so now we're at 21%, but still 30%. I'll try one more time. Otherwise, let's try to see if we can do this a little better, right? Okay, so it is just variance. Okay, 81%. We have a pretty efficient solution. Okay, bada bing, bada boom. There we go. So, okay. As always, in all my videos, I do a quick recap if I was able to solve the problem. So for this one, I won't lie. I have solved this problem before and so on. This is just sliding window. And the reason I was able to do this problem so efficiently is because this is actually a super important problem. In fact, in a lot, I think I've only done like, less than 10 of the weekly LeetCode contests in total. And I think in like 3 of them, I needed this exact algorithm as part of the solution, right? Where it's like you need to have like, the longest non-repeating substring at some point, so on, do some more work, bada bing, bada boom, some dynamic programming solution and so on. But it's like as part of the problem itself was this problem nested inside of it. So it's like a very, very like common problem, at least in LeetCode, to, be able to find the longest non-repeating substring, or, the longest, like some maximum palindrome, that's a DP algorithm and so on. But usually there's a lot of these sliding window type ideas where you find the longest something substring and so on. So here, without repeating characters, is very straightforward. The way that I was able to solve it is essentially you're going to start from the very beginning of the string, right? And the point is you're going to keep moving forward until you hit a repeating character. And the way you're going to do this is essentially I have a hash map here, or a dictionary D, where it's like for every single letter inside of S, I'm going to add that into my dictionary, right? Now, if this is the first time that I add this into my dictionary and so on, so essentially these are going to map letters to counts, right? So it's like for every single letter in S, right? So yeah, for every index R in the range of length of S, letter is equal to S of R. So essentially for every letter inside of S, we're going to say, okay, the hash map letter value is going to be take whatever current value is inside of there, right? So d.get the value at letter, otherwise 0, right? So whatever frequency is this letter, grab it, and if it doesn't exist, 0, plus 1, right? So essentially increment the frequency of this letter because we've just seen it one more time right now, or otherwise if we've never seen it before, then add 1, right? And now every time we add a letter, it might be the case that this is the second time that we see this letter, right? And that's a big no-no. So what we do is say, hey, while it is the case that this letter is a duplicate, we're going to essentially keep going from the beginning of our array until we've removed it, right? So essentially, the point is that you're going to go for the very beginning of the string, right? So like if we take a string like S over here, right? A hashtag this, we're essentially going to keep going through the entire string, right? So we're going to have, like think of this as like a hash map, right? So here we have like, D, we have A inside of it. Here with value of 1. All right, we added this A. We're going to add this B. B is not inside of our dictionary, so this is good. We can just put it in here. This is very nice. Let's look at C. Okay, C is not in here. Let's just do this and so on. There we go. And now we add A. Okay, let's increment A's value and so on. Oh, wait a minute. This is a length 2. So far, we've seen the string all the way up to here. But this is not a valid string, right? Why is it not a valid string? Well, because it has repeating characters, right? So we've just introduced a repeating character. So the solution that was right before is a potentially optimal solution. It actually happens to be the solution, right? The answer is ABC. But we don't know that yet, right? We need to traverse the rest of the string, right? But for all we know, we could have like W, X, Y, Z here, which is of length 4 and non-repeating, right? So ABC, we have this. And now we just introduced a repeating character. So the idea is that we're going to come from the very left here, right? And essentially keep sliding the window down until we reach a string with no repeating character, right? So we're going to keep coming from here and removing characters until it is the case that, A, which is the only repeating character, because up to this point we had no repeating characters. We just introduced one, which is A. Then we're going to, so while, A is of greater than 1 frequency, we're going to delete letters from the left, right? So here, essentially, this is where our left pointer was. Whoops, let me make some space. So this is where our left pointer was, and our right pointer is currently here, right? We just added another A, right? So the idea is like, while it is still the case that, A's frequency is greater than 1, we're going to keep deleting letters from the left, right? And so far, the biggest string that we've seen is of this length, right? So max length, we'll call it, is equal to 3 so far, right? Because it was here, R minus L is, 4 minus 1 plus 1 is equal to 3. There you go. And so from here, it's like, okay, let's delete this character here and update our left pointer, right? So let's update our left pointer to here and delete the fact, that letter right there, right? So here, let me do space and L, and here decrement that letter. And the letter that we actually decremented was A itself. So in this case, that means we have no repeating characters. Here you can see that immediately because they're all value 1. So we can keep going, and this is another valid solution. So we update, okay, this is of length 3 here. So, max of 3 and 3 is still 3, right? And now we just keep on going. So let's keep incrementing our pointer here as long as we keep going. So here we update it to here, increment the value of B by 1. Oh my goodness, this is a duplicate character, right? So we're going to keep moving our left pointer until we find a until we delete a B, right? So in this case, we're going to delete this letter that's here. So we're going to decrement the value of B here. We're going to, move this L away from that B. And then, oh my goodness, the letter we actually deleted was a B, so we can stop here, right? Here, this is another possible case. This is length 3 as well. Okay, so now let's move on. This R, we're going to move it here. Okay, but this is another case of this C, right? So we just incremented this by 1. Now we need to keep deleting letters from the left until we delete a C, right? Here just so happens that every single case, the very first letter we delete from L is the letter that we needed to delete itself. But you could imagine, if L was over here, for instance, right, we would have to delete this A, and then we'd have to delete this B, and then we'd have to delete this C finally in order to delete that repeating character, right? So like that's what you need to be careful of. Okay. Okay. Okay, so we were here, and yeah, so now, yeah, we were at the C, we deleted that. We're moving this L over here. And there you go. Okay, so we're still at length 3 and so on, and now everything's all good. So now we're going to increment our right pointer and increment this B by 1. Oh my goodness, we're at a 2, so we need to keep deleting characters until we find another B, right? So here we're going to delete this A here. Right, so delete this, so this actually becomes 0. So we have 0 frequency for the A here. Then it's like, okay, we still have a repeating character, so we must keep deleting characters, right? So here we're going to delete whatever characters over here, right, which actually happen to be a B. So we decrement this by 1. Okay, we no longer have repeating characters and so on. We compute the max length. This is of like 2 and so on. There we go. And then, move on the R. Here there's a B, so that's a repeating character. So you know what, delete this character over here, whatever it is. So here that was a C, so let's delete that. That's a 0. That's still not a B. Let's delete this character over here. Our left and rights are actually on top of each other here in this case. There we go. And now we deleted this B, so it's like, oh, this is good. And then we reach the very end of the string, right? And so we update that one more time and so on. But the point is that I update it every single iteration. It's just that, like, whenever I add a new character, if it happens to be that caused, a duplicate entry, right? If D of letters value is now greater than 1, then we're going to keep deleting the character at our left pointer, incrementing our left pointer as we go until we no longer have repeating characters, right? And at every single iteration, right, whether we fix ourselves or not, right, we're just going to keep updating, the maximum length substring that is valid so far, a non-repeating, up to this point over and over and over and over until we reach the very end, in which case, we've considered every single possible legal case of non-repeating substrings and that are, contiguous, not subsequences. And there you go, bada bing, bada boom. We just return, the maximum of all the results, which is just res here, right? So hopefully that explanation makes sense. Again, it's kind of like a sweep, right? So that's why it's called like sliding window. It's like, you kind of have a window with like your left and right pointers. It's like you increment your window with this right pointer here, but then it's like, oh, you find a duplicate character, so then you like close the window until there are no longer repeating characters, and then it's like, you keep opening this window, oh, repeating character, close the window until there's no more repeating, open, close, and so on, etc., right? Until you eventually, every single time, updating the max length of a non-repeating substring that you've seen so far over and over and over until you reach the end of the string, in which case you just return the maximum result that you've found so far, bada bing, bada boom, and then you just return the solution. And as you can see, very efficient solution, 81%, which just feels very nice and good. But otherwise, let's make sure that we check the fact that we did this problem. So there we go. That was problem number 38 of the NeetCode 150 challenge. We're getting there slowly, but nevertheless surely. So otherwise, that was pretty much it for this video. If you did find it useful or enjoyable in any way, shape, or form, I'd highly appreciate if you left a like or a comment. But otherwise, I'll catch you in the next one. So until then, ciao, ciao, my friend. Bye-bye.